Welcome back to week 2. Congratulations on finishing week 1. That's pretty grueling. It's an unpleasant collection of things that you have to do without understanding them, which I hate doing, and I hate doing it to you, but you're ready to go now. You've got a real system, a real dev environment that you can actually start doing some programming, so you can start doing what we're going to talk about today, which is actually programming. So let's actually learn something this week. So what are we going to learn? Python syntax, and we're going to learn a few other bits and bobs. So a couple of things about your environment, what we're really talking about when we say tests, the concepts of decomposition and abstraction, a bit of how to use your editor, and what Git and GitHub actually are. Okay? So let's get into it. There are 7 things that you really need to understand to be a programmer. And once you have all of those concepts, everything else is either not programming, it's like software engineering or computer science or something like that, or it's a refinement of one of these concepts. These concepts are pretty universal in most programming, I won't say all, and so getting to grips with them is going to be useful. So they are values, variables, expressions, functions, collections, flow control, and iteration. You might see them called other things in other places. They might be called different things in different languages, but in Python, this is what we're going to call them. And so we're going to go through all of them and learn everything to do with Python. So if you want to play along, you can open your terminal in VS Code, and if you just type Python, you'll get an interactive prompt, is what we call it. Some people will call it a REPL, which is read, evaluate, print loop. But basically, it's a place where you can type Python and it will do stuff. So if you just want to try it out and see what happens, you can do that. All right, so the first one of those things is values. And we're going to go through each one of these things in turn. All right, so first one, values. So values are the kind of useful stuff that we're actually working with. So you can have different types of value, and the concept of types is very important in programming because you can do different things with different types of stuff. That said, Python has a slightly strange view of types in some people's ideas, so we'll talk about that a bit later. But the big ideas that we have to deal with here are these are the sort of main types of thing. Okay, so types, this word comes up over and over again because a lot of programming, initially at least, was done by people who had a really strong interest in linguistics. And so the word type is the obvious thing to describe the type of the thing that we're dealing with. So sometimes it's a bit tricky to try and understand what you're saying, but here we go. So the most obvious kind of number that you would come across in a computer is an integer. I'd never come across the concept of an integer before I started programming, so there's a pretty decent chance that you haven't. It just means a whole number, a counting number. So 1, 5, -4, 1,000, 500 billion, that kind of thing, and 0. So those numbers which you would say, how many of these things are there? Those are integers. Okay, so when you come across an integer, or an int as people call them, that's what they're talking about. And then the other type of number, which I think mathematicians call natural numbers, are floats. So that just means floating point decimal. It's a weird thing about how they are represented inside the computer, and it's a bit of an abstraction that leaks from the inside. So basically this just means decimal number, basically. And so that's numbers like 0.5, 1.0, -7.8, that kind of thing. And those are used for continuous values. So how tall are you? You're probably like 165.3 centimeters tall, or something along those lines. You would probably have an integer number of fingers, right? So you probably have like 4 fingers and a thumb, or 5 fingers, depending on how you define it. And so those are the 2 types of numbers that we really come across in Python. There are more specific types of numbers in more specific situations, but I've never had to actually use one. I know why you would use one, but I don't work for a bank. So I don't work for a bank. I don't work for an engineering company. I don't need to deal with that kind of precision or accuracy. So everything I've ever needed to do has been an integer or a float. So it'll be a long time before you ever need to worry about that kind of thing. All right. So those are your numbers out of the way. Then we have Boolean values, and we see them written as bool. And so Boolean values are named after George Boole, who was a mathematician guy from the 17th century or something along those lines. His whole family were geniuses. There's a bunch of articles about it. It's super fascinating. Check it out sometime if you want. But they basically describe binary logical questions. So, am I alive? And we can avoid the existential angst there. True. I am true. It is true that I am alive. Do I have 500 fingers? False. It is false that I have 500 fingers. Am I more than 100 centimeters tall? True. I am more than 100 centimeters tall. So those kinds of Boolean questions are used a lot to control what a program is going to do. Is the stock price of Tesla above $100? If so, do something. If it's not, do something else. And then the last one is the string. And strings just mean strings of characters. And so what we would usually do with that is make text. So you want to write something down. Last week you wrote hello world. That was a string. So hello world. You can also put some numbers and treat them as a string, and they won't be treated as a string by the computer. They won't be treated as numbers by the computer. They'll just be treated as the characters 4, 5, and 0 jammed together, not as the number 450. Okay, so that's values. The next one is variables. Now, variables are what makes programming actually useful, rather than just having a list of things that you're supposed to do with these numbers or these values or whatever. You can say, hide my value inside this variable and treat it as a thing you can pass around. And so if you did algebra at school, you'll be used to that concept where you say x equals 12, 2x, what does 2x mean? It's 24, that kind of thing. And so we can put the value 42 inside my variable, and then we can get it out again. And so this little arrowy bit here, you don't type that. That just shows that's a kind of convention that says we're typing this in an interactive session. So an interactive session is what you're doing if you're playing along at home. If you are not doing that, you can just ignore those little arrows altogether. And so this number 42, the value, and this word, my variable, is the variable name. So the way you name things is actually really important. It doesn't matter to the computer that much, but do you remember last week we were saying that programs are written for humans to understand and only incidentally for computers to execute? So if your variable is named my crap variable or X or L, never name something L, because how do you know if that's 1 or I or anything like that? It's impossible. So having good names makes your life way easier and makes it much more self-documenting. And as a guy I used to work with used to say, keystrokes are free. So the computer doesn't care. If your variable name is 100 characters long, it will treat it exactly the same as a 1 character long thing when it's executing it internally. It doesn't care how long it is. So make your variable names descriptive of what they're doing. And this is the assignment operator. It's not doing a comparison. Like in mathematical notation, a single equals says x equals 5. It means that x is equal to 5 and 5 is equal to 5. And so it's saying that they're comparable. What we're saying here, and in some other programming languages, this is an arrow. So what it says is we're putting the number 42 inside the wrapper my variable. Okay, so we've got this thing we say my variable equals 42, and then when we type out my variable and press enter, it will give us back the number 42. Now, the magic of variables, and particularly in Python, which doesn't have a strong typing system, is that we can then put something else in there. And so we can say my variable equals hello. And so we put hello into there, and then we ask for my variable again, it'll give us back hello. So even though it was giving us back 42 before, once we changed it, we can make it give us back hello. So that's a very powerful concept that will take a while for you to really kind of get your head around. Okay, so the next thing is expressions. And expressions are something that you can resolve. So this thing on the right here, so 4 times 10 plus 2, is an expression, okay? And they respect a bunch of precedence laws. So the way I was taught it was BODMAS. If you're an American, sometimes it's called PODMAS. I don't know what they teach here. I think it's BODMAS. It just means brackets of division, multiplication, addition, subtraction. And it just means do those things in that order. So in this case, it would be 4 times 10, which is 40, plus 2, which is 42, right? Like, the maths in programming is actually almost entirely super easy. If you can add 1 to a number, then that's most of the maths. Sometimes you'll have to add 2. All right, so that's the equivalent of putting those brackets in. You can put them in for readability. Sometimes it's nice to do that anyway. Right. And sometimes you get expressions which, like when we said print hello world last week, this whole thing is an expression. So we're going to print hello and then it does something. The expression resolves to return a value of hello. Okay, so we don't necessarily have to have an assignment to that expression. And remember this, we just talked about it again, so we can talk about it again. So this whole BODMAS thing also applies when you're doing other comparisons and that kind of thing. So if you're saying do something, then do something else, then do something else, you can manage that by putting brackets in. It's often not as important as you think it is, but it usually adds to the readability of your code to just put the brackets in just to make everyone's life a bit easier. Right, so functions. Functions are something we do a lot of in programming because they do a few things. One is that they improve the reusability of your code. So if we look at this code, we can say hello, for instance. And this is a function taken from the exercises. And so let's say we need to say hello a lot of times every day. We can call the say hello function without having to think about how it's being done inside. And over time we can improve the insides of that. It doesn't matter, but it's just saying say hello. And so when we define it, and I think we go through this quite carefully here. Okay, so this is a line continuation. So that means that when we go onto this line, it's just carrying on a single thing across a few lines. Then this bit, the word def, tells the computer that a function definition is about to come. It's following the word def is a function definition. And then we have the name of the function. And again, naming things is important because it does what it does. You know, if you're a big Harry Potter or Earthsea fan, you'll know that naming things is important in those worlds. Naming things is important in our world. And then these are the arguments. Arguments is a word that doesn't really get used in English to describe anything other than throwing plates and shouting at each other. And so this use of the word arguments is kind of only in programming. So what it means is the variables or the values that are being passed to the function so that it can do its job. So we use the chef or the recipe concept a lot. If you have a recipe that says fry this thing, or fry the onions is the variable or the argument. And you could also have fry the garlic, where the fry is the function and the garlic is the argument that you're passing. Okay, so yeah, we're going to cover that in a bit later. So then there's just a colon, and the colon is syntax to say, okay, I'm done with this line now, carry on with the next line. What it basically means, whenever you see a colon in Python, it means that you're expecting an indented block. So you put 4 spaces and then start the next line. That 4 spaces is super important because Python is a white space indented language. So often if you have a problem, it'll be because you've forgotten that colon. Okay, so if you look at how this function works, what it's doing is it's saying, okay, we want it to say hello, and so we're going to print, and then the word hello, and then a space, and then add your name, and then add an exclamation mark, and then it will print hello Ben. Now you need to be a little bit circumspect sometimes of what a function does. You don't always have to check, sometimes it's very difficult to do that, but sometimes functions will do things that are unexpected. They'll have what is known as side effects. And so side effects are sometimes very helpful. Like side effect of a function might be to turn the lights on or something like that. But it might do something like call another function that says send to the NSA, and it sends all your phone numbers to the NSA or something along those lines. So just be sort of careful about when you're calling external code, unless you wrote it, just have a think about where it came from. Right. Collections. So we've got a function, we've written a function, it's great. And you want to say hello to one person, that's great. You can say, call the hello on Ben. What if you've got 500 people and you want to do that? You don't want to have to type out, say hello, name 500 times. You want to be able to say, for each person in this list, say hello. So using collections, and I like to think about these as egg boxes with only one row. I don't know if egg boxes with only one row exist, so if anyone has one, if it's a real thing, I would love to get one and I can wave it around and be like, look, like this. We define lists, and lists are a type of collection, probably the most common type of collection, with square brackets. And we index the things in that list from 0. So the first thing in the way we count in English is the 0th thing in the way we count in programming. So we've got our lists, and they can be homogeneous lists, which means all the same, like homo, same, or heterogeneous lists, like this one, whereas hetero means different, right? So we've got a homogeneous list of numbers and a homogeneous list of strings, and then we've got a heterogeneous list of strings and numbers, or specifically integers in this case. So lists are just sort of useful. They're just a place where you can keep stuff. And so you can use them for keeping things, you can use them for something that you're going to operate on later. They're just a concept that we use a lot, and you're going to use them a lot in this week's exercises. There's a very similar thing to a list called a tuple. Tuple is just a generic term for the number of things like double or triple or quadruple, that kind of thing. So tuples get used a lot by library people. When you use a library, it often will do stuff in a tuple. I've never needed or wanted to use a tuple, but you just have to know they exist, because when you get a list and it comes with round brackets, you're like, oh my god, I can't deal with this because it's not a list, it's going to break or something like that. You just need to know what's happening. So they're not functions. They have round brackets. Functions have round brackets, but they're not the same. Sometimes concepts get reused. So the word in gets reused, for instance. But tuples are a pain. They have arguments for using them, but none of those arguments are particularly convincing to me. Now, probably the best type of data collection that you can get is a dictionary. Dictionaries are great because they're self-documenting. They are very versatile. You can do all sorts of stuff with them. And they have this concept of a key-value pair. So a key-value pair is like the key, which is the name of the value, and then the value, which is the actual value of the value. So easiest way to do this here is to say, well, we've got a dictionary of this cake, and the name of the thing is cake, and the taste of the thing is delicious. You can put anything you like in a dictionary. So this one is a dictionary with a string, and this this key value pair as a string in a list. And you can nest these things arbitrarily. You can put as many times as you want to do that. So here we go. We've got a list, and then we've got a dictionary. So the list is just some integers. The dictionary is talking about this cake again. We've got a little tuple that's got 1, 2, and hello. They can be heterogeneous as well. And then we've got another list. Now that list is made of the list and the dictionary, or the dictionary and the list, right? So when we print that out, we can see that we have the square brackets for the list, or the staples as some people like to call them, like that. And inside that we have the curly braces, which define the dictionary. And so we've got the key, which is taste, and the value, which is delicious. And so that dictionary is inside a list. And this list is inside a list. Okay? So you can keep nesting and try and figure this out. And then it's just, you can store data however you want. And I think in a few weeks' time we have an exercise that really drills into that, where we get a whole bunch of data from the internet and you have to like walk down into it and find out what's going on. It's sometimes it can be a bit annoying, but it's nice to be able to structure your data however you want. Okay, almost there. Now, this is the real powerful stuff in programming, because if programming was just a series of commands, then it would be incredibly tedious. John Maeder talks about automating the accounting system in his dad's tofu factory, and he wrote something like 10,000 lines of code to do the accounting. And then he learned about flow control and iteration, which is the next one, and he cut that down to, I think, 1,000, something along those lines, because you don't have to repeat yourself over and over again. And this is where the magic comes in. So we've got to make decisions. 69 smaller than 88. And so what this does is we use another like word here, which is resolve. Does this resolve to true or false? So if we're in a like face-to-face situation, I would ask you, is 69 smaller than 88? And the answer is yes, it is. So that's true. It is true that 69 is smaller than 88. And so if true, print, well, that was obvious. Okay, so that's what it does. And now that's not that helpful if you just have a number, because you could do that in your head. The computer will always resolve the same way. So we want to use variables to do these things. So these variables could be anything. They could be heights, they could be year of death, or whatever. So depending on what we're going to put into these variables, this thing will resolve in a different way. So here we have, is Dolly Parton bigger than Biggie Smalls, or greater than Biggie Smalls? And so if that's true, so here we're doing it on ages, right? That will print that phrase. You'd be surprised how much it costs to look this cheap. Classic Dolly. All right. Now, we also want to have a situation where if that's not the case, if it's false, what will happen? And if it's false, it prints, if you don't know, now you know. So that else handles all situations where the first one is not true. But what sometimes we want to do is say, well, if that's not true, let's do a different test and see if that's true or not. And so in this case, integers can be equal, right? So if Dolly Parton equals Biggie Smalls, or is the same as, and that double equals sign is the Boolean comparison for equality. So if this value and that value are the same, then give us back true. Then it will print Notorious Jolene, which is actually quite a fun remix. Otherwise, it'll print, if you don't know, now you know. So what we're dealing with here is this decision-making system that allows different bits of code to run depending on what the value of those variables is. The last one, this is where it kind of gets magic when you start to add these things together, is iteration. Iteration just means to do something over and over again. Reading a book is iteration. You turn the page, you read the page, you turn the page, you read the page, turn the page, you read the page until you run out of pages, and then you put the book down. Or any process that you do over and over again can be described as iteration. And so this is a kind of classic Python thing. So we've got a list of numbers and then a little string at the end. And so this code here will say for bottle count, where we're defining the word bottle count to be used inside this loop. So we're looping around. Sometimes people call iteration loops. In fact, most of the time. So inside this loop, this is a for loop, the bottle count. So for each bottle in the list on the wall, so if I expand that out, for each bottle in the list on the wall, call it bottle count, and then we're going to go into the thing. We're going to print there were, and then we need to make a string of the number. There were how many bottles? So the first one will be 10 green bottles hanging on the wall. And then we go back to the top, and bottle count gets redefined because we're popping the next one off the list. And it'll say there are 9 green bottles hanging on the wall. And so on and so on and so on. And then when we get to 1, it'll go, there are 1 green bottles. And the last thing in there is there are no green bottles. And it'll print that. So that's nice. You sometimes see this where you're trying to do something based on a number. That's actually much less common in Python. You see that a lot in JavaScript or C style languages, but in Python we don't do this very often, which is very, very nice. So with those 7 things, you can do pretty much all of programming, which is nice, right? You've kind of learned everything about programming. So the rest of this term is basically just going to be learning how to apply those ideas. There's not really much else that you need to know. So we're going to get into a few concepts of how you might do things, but you've learned everything you need to know to actually do it.